Everybody, welcome back to another AP Precalculus video.
Today we'll be going over FRQ Type 2.
Just some reminders about FRQ Type 2. So we're going to be modeling a non-periodic context, which covers material from units 1 and 2. It is going to be calculator active, so it is on the calculator portion of the FRQ part. And it is 3 parts. So we have part A, part B, part C. And these are what each of the 3 parts are going to consist of. And we're going to be going in depth into an example so you can see these concepts being used.
So this is the FRQ we are going to be going over in this video. You can pause and do it yourself if you'd like.
All right, so this is part A1, and first let's just take a look at the question. So on the initial day of sales, t equals 0 for a new video game, there were 40,000 units of the game sold that day. 91 days later, t equals 91, there were 76,000 units of the game sold. The number of units of the video game sold on a given day can be modeled by function g, given by g of t equals a plus b ln t plus 1, where g of t is the number of units sold in thousands on day t since the initial day of sales. So part A1 is saying use the given data to write 2 equations that can be used to find the values for constants a and b in the expression for g of t. So we're going to plug in values for g of t and t into the given equation because we are given values already. So when t equals 0, g of t, units sold in thousands, is going to be 40. And when t equals 91, 91 days have passed, g of t is going to be 76. We're getting the information directly from the question right here. All right, so using the equation of g and t, we can plug in our t values and our g of t values into this g of t equation, and then that'll give us a system of equations that we can use to find out our constants a and b. So it's pretty easy, you just plug it in. So we have 40 equals a plus b, ln, and then the corresponding t value is 0 plus 1. Then we do the same thing. So we have 76 equals a plus b, ln 91 plus 1. This is going to be our answer for A1. We're just finding those system of equations simply by plugging in our values. Something important to note is that you do want to state out the information that you're given. So since g of 0 equals 40, g of 91 equals 76, that's what we're given, and these are our equations. All right, so part A2 is going to be a continuation of, obviously, part A1. And this time, we're actually going to find our A and B values. So we're going to be using those system of equations that we found in A1 to find A and B. All right, so right here, we have the system of equations that we found earlier, and we have our steps. So let's just take a look. And you want to make sure that you're showing your work. That's super important for getting as many points as possible on your FRQ. We're just going to be doing some algebra, and we're going to ultimately use substitution. All right, now the first thing to notice is that ln of 1 is 0. So if we wrote this out, a plus b, anything times 0, so no matter what b is, times 0 is going to be 0. So we can automatically make this into a 0. And then we have our 40. So a equals 40. So that's your first constant that we found. And we don't even need to put this into the calculator because we just straight up got 40. All right, we're going to plug 40 into our other equation to find b. So 40 plus b, we can go ahead and simplify this. 91 plus 1 is 92. ln 92 equals 76. All right, and we want our b alone. So we can subtract 40. So we have b ln 92 equals 76 minus 40. And then divide by ln 92. So then we have b alone. Right? The question is asking for decimal approximations. So obviously 40, we don't really need to do that. But for b, we want to calculate what this value is in our calculator. So we're going to go over to our calculator, and we're going to do 76 minus 40. And then we're going to divide this by ln of 92. And this is our approximate answer. Now, we also want to talk about rounding or truncating. So AP graders will look at 3 places after the decimal point. So at the very least, you want to get it to 7.961. So that is what our p value is going to be. All right, and now that we have our A and B values, now this technically wasn't asked in the question, but just to be safe, I do like to plug my A and B value back into the G of t equation. So we have G of t equals A, so we have our 40, plus 7.961, and then our ln equals 1. And again, I know the work is a little condensed here, but work from the whiteboard or in this form, it's all acceptable, as long as you have some work to show on how you got your answer.
Okay, guys, so now we're on part B. And for part Bi, it's asking us to find the average rate of change of the units of video games sold. So if we recall the formula that we just found in part A, which is G of t equals 40 plus 7.961 ln of t plus 1, we need to plug in points into this to find our average rate of change. So we would do G of 91 minus G of 0 over 91 minus 0. And since this is a calculator-based question, we can put G of 1 into our calculator. So here's a calculator, and we would click Y equals, and we would just type in the equation. Okay, now we have our equation. So if we click second quit, we can do alpha trace y1, which is G of t, and then now our t value is going to be 91. And we subtract G of 0. And then now we do this over 91 minus 0, which is just 91. And then we will get 0.39573, which is our answer to the question. But we need to make sure that we answer the question in terms of context. So answering the question in terms of context, it would be the average rate of change is 0.395 thousand units sold per day. And here I included a bunch of decimals, but on the AP exam, you can just include 3. Okay, guys, so next we will be looking at part B2, and it's asking us to use the average rate of change that we just found to estimate the number of video games on day 50. Okay, guys, so this is my work for part 2 and how I approached the problem. So recalling point slope form, which is right here, I moved y1 to the other side, and since this question is g of t, I made sure to put everything as g. So using the slope from the first part, I plugged that in for r, and then I needed to use the points from this question. So you can either use 0, 40 or 91, 76. It doesn't matter, you should get the same result. So then I plugged that in, and so g of t1 G of 0 would be 40. And since we're using time equals 50, we're plugging that in for t. And t1 is 0 from our point. So once we plug that all in, we should get y equals this number. And then we can simplify this in our calculator. Also, we want to use this exact value for r. We don't want to use like an approximation, because that may change our value and we don't want to risk that. So we could store this as a letter just using the store function, which is right here. And I'm going to store it as P. So now every time I enter in P, I should get the same value. Okay, so now I need to add everything together. So then I get my answer, which is 59.786. So we need to make sure to answer the question in terms of context to get full points. So then we would get on day t equals 50, approximately 59.7802 thousand game units were sold. So moving on to part B3, we are asked to show that G of t is greater than A of t for all t between 0 and 91. I personally do not like this question. I think it's kind of hard to understand. We need to find A of t first, and we're told that A of t represents the estimate of a number of units of video games sold in thousands, and it's telling us to use the average rate of change that we saw for in the first part. So all we have to do to find A of t is use our average rate of change. So that would be our slope. And then we're going to have our y-intercept be 40 because we know that we have a point at 0, 40. So we know there's a y-intercept there. So now that we found A of t, we want to plug this into our calculator. And since we stored the value in the previous part, I could just do that instead of typing out the entire decimal. Okay, and we also need to plug in G of t into our calculator, and we did this in a previous step, so it's already there for me. Okay, now we need to graph these functions because we're trying to find that G of t is greater than A of t for all values from 0 to 91. So we want to make sure that's accurate first. So let's set our window to 0 to 91 because that's our interval. Okay, our window for the y value is way too small, so I'll just make it 100. So we can see here that G of t, which is this concave down function, is greater than A of t for all these values. Because the graph of G is concave down on this interval, and we can see that the secant line is below the graph, we can tell that G of t is greater than A of t for all values 0 to 91. So this is how we could answer the question to get full points. And we're just saying that because the graph of G is concave down on the interval and the secant line passes through the points 0, G0 and 90, G of 91. We can therefore tell that the estimate AT is less than the value of G of t for all t on the interval 0 to 91.
So lastly, we have part C, and it says the makers of the video game reported that daily sales of the video game decreased each day after t equals 91. Explain why the error in the model G increases after t equals 91. So when we're talking about the error in the model, we're talking about the difference between what our G of t equation is predicting in terms of sales versus what's actually happening. So if we recall our G of t equation that we found in part A1, that is going to be our y1 that we found earlier. And we're talking about the behavior of our G of t equation after 91, after t equals 91. So we want to change our window. We'll make the minimum 91, and then for the maximum, we'll make it like 200 maybe, just to look at it. All right. So you can see that it's a little hard to see, but you can see there is an increase. So the GFT model that we created is showing that the sales are increasing on our interval 91 and so on. So that means after t equals 91, we're still increasing. But the information from part C says that our sales are actually decreasing. So because our prediction is increasing and the actual behavior of the sales is that the sales are going down, as t increases after t equals 91, the difference in the values is going to increase. Just to visualize it, if our GFT model is increasing like so, but our actual value, if this is going to be e equals 91, and so on. So if our GFT model is increasing like so, again, it's not very accurate, but we just need to see that it's increasing. And from t equals 91 and so on. And our actual behavior is that the sales are decreasing. So if we have like from, let's just say like here to here, as this keeps decreasing and as this keeps increasing, the difference is going to get larger and larger. So that's basically what's going on here. You want to explain this relationship in the answer, and it's important to note that to start off, g of 91 and what we're given is equal, but then from there, we start diverging. Thank you guys so much for watching the FRQ Type 2 video.
Stay tuned for more math lessons in practice and make sure to subscribe. Bye!
Bye!